Do you like boba? Have you been to a froyo place and wondered how they make those little fruity spheres that burst in your mouth? Hello and welcome back. My name is Alex from Nourish Chicago, and today we are going to be talking about the science of reverse spherification and how you can make your own boba at home. Before we get started, in this recipe you will need a bag of sodium alginate, distilled water, a bag of calcium lactate, and a flavoring liquid of your choice. To begin, you are going to want to measure out 2.9 grams of sodium alginate into a bowl and mix it with 3 cups of distilled water. Blend this mixture to ensure it is evenly mixed and then let it sit for 2 hours. This allows the mixture to lose any bubbles it might have. One question you might have is why distilled water and not regular water? That is because tap water contains different ions like calcium, which are important for us, but it can mess up the ratios in our experiment. While the sodium alginate solution is setting, you can prep your flavoring liquid. In this demonstration, I'm going to be using kefir. When you're selecting your flavoring, you want to check the nutrition label and ensure that there is at least 20% of the daily recommended calcium. If the calcium concentration is below 20%, you can add calcium lactate, 200 milligrams per gram. Once you have ensured your liquid has the proper amount of calcium, you want to check the liquid's viscosity. Now, viscosity is the scientific word to describe how thick or thin a substance is. We would say water has a very low viscosity, while something like cream has a higher viscosity. In this demonstration, you want your liquid to have a high viscosity, almost like the thickness of yogurt. If you are using juices, you can always add cream or other alternatives to thicken up your liquid. Another important factor to consider is pH. For those at home wondering, pH is the measure of the amount of hydrogens in a given solution, which affects the acidity of it. A low pH means more hydrogens are there and vice versa. For our experiment to work, we need a pH between 4 through 10. What we're going to do is we're going to be using pH strips. And as you can see here, the colors on the strips will indicate what pH we're at. So I'm going to take a pH strip right here, dip it in the yogurt, clean it off a little bit, and then we wait. And as you can see, there's been a noticeable color change. We're going to go here, and we're going to check to see what that pH looks like. And if you look here, it looks like it's about a pH of 5, which is within our range. So we know that the boba should form and that we're good to go. Now that your liquid is the right viscosity, you're going to want to grab a spoon or syringe. I would recommend rubbing the olive oil on the spoon to prevent sticking. I'm going to pick up our liquid and make a drop into the sodium alginate solution. Once the liquid enters the solution, wait 2 minutes. After time has passed, you are going to want to strain it out and run it under normal room temperature water. And voila! Your very own boba you made from home. It's really good. Our curious young scientists at home might be wondering how this works. Well, I'm glad you asked. Let's talk about the science behind reverse spherification. So, when you buy your sodium alginate, it's going to come with alginate, which has carboxylate groups on it, which gives it a negative charge. And it also has sodiums. Now, if you remember, sodium has a positive 1 charge, which cancels out the carboxylate's minus 1 charge. Making the whole thing neutral. But when we add our sodium alginate into solution, what's going to happen is that the sodium is going to travel away from the alginate, freeing up these negative charges, which is important for what we want to do. So, when you add your calcium-rich food liquid, it's going to come in, and if you remember, calcium has a +2 charge, meaning it can bind to more than one negative carboxylate at once. So it can come in here and interact with 2 separate alginates allowing them to clump together. So, when you add it, eventually, it'll start creating that sphere on the outside of the different kind of clumps of alginates. And then, the calciums are going to act almost like a glue to bind them together, thus giving you your boba. If you find yourself struggling to make boba, I would recommend using pH strips to check the acidity of your liquid. You want it to be between 4 and 10 for optimal results. Thank you for joining us today. Now that you have seen me do it, follow along with your Nourish Chicago volunteer, and thank you for watching.